For this question, a solid is heated and it's melt at a constant temperature. Remember, whenever the temperature is constant, because temperature and kinetic energies are directly proportional. So if the temperature is not changing, the kinetic energy, the molecular kinetic energy should stay the same or it should be constant. But what happened to the potential energy? When a substance is melting, the particles move away from each other. As a result, the potential energy will increase. So it will be kinetic energy stays the same and potential energy increase. That's why option C will be the right answer. In question 12, the zero on the Kelvin temperature scale is known as the absolute temperature. What is the description of absolute temperature? Basically, what happened at this temperature, like the molecules, the particles have the lowest kinetic energy. As the temperature decrease, the kinetic energy will also decrease. So at absolute zero or 0 Kelvin, the particles have the lowest kinetic energy. That's why option C is a valid answer. So for this question, we have a mixture of a helium and hydrogen gases are there, which are maintained at a temperature around 300 kelvins. So the average kinetic energy of helium molecule, EK, and their average speed is V. Which statement is correct? Remember, because if they are at the same temperature, means they will have the same kinetic energy. So kinetic energy of the helium will be same as the kinetic energy of hydrogen. But because the helium molecules are massive, like compared to hydrogen, they have more mass, so they will move slower. Where hydrogen molecules are lighter, so they will move faster. But the half mv square for the kinetic energy of helium will be same as kinetic energy of hydrogen. So average kinetic energy of helium, so this is totally wrong. It's not less. Then average speed of hydrogen molecule is less than like average kinetic energy of H2 molecule is less than Ke, that's wrong. The average kinetic energy of hydrogen molecule will be same as Ke, that is true. Like because it's at same temperature, so when we have two different gases at a same temperature, the molecules they have the same kinetic energy. They might move with a different speed, they will have different masses, but the kinetic energy will be same for them. So in question 14, if hot liquid wax is left to cool and it start to solidify at 45, means when it solidify, the temperature does not change. The temperature won't change when it solidify. The temperature of the wax will remain constant. Which row correct? So if the temperature is not changing, the kinetic energy will be same. But what happened when a gas turned to liquid or a liquid turned into a solid? The potential energy of the particle will decrease. So that's why option C is a valid answer for this. So for this question, we have hydrogen and nitrogen is used to inflate a balloon. On average, so we can use a mixture of hydrogen and nitrogen to fill up the balloon. On average, nitrogen molecule in the mixture are traveling at the same speed. Normally, when we have a mixture of the gas will be at same temperature. So they will have the same kinetic energies. When they will have the same kinetic energy, because the nitrogen is like N2, which is 28, where hydrogen is H2, it's only 2. Because the nitrogen is having more mass, so its molecules are moving slower. Where hydrogen is have lighter, so its molecules are moving faster. But the kinetic energy, half mv square, for nitrogen will be same as half mv square for hydrogen. As in inflated balloon, the temperature of a gas will be same. So they won't move with the same speed, that is wrong. Nitrogen are traveling faster than hydrogen, that is also wrong because nitrogen molecules are heavy, so they will move slower. Have same momentum as hydrogen molecule, Look, their kinetic energies will be same, not the momentum. Because the momentum is a product of mass and velocity only. Kinetic energy half mv square. So they will have a great, so they don't have, because the product of half mv square will be same, but not the product of mv is same. The product of mv will be different for both of them. And because the nitrogen molecules are relatively heavier, like 28 compared to, so 1 is to 14 is a ratio, so much massive. That's why they will have a greater momentum than hydrogen. So, and also remember the formula which relate the kinetic energy, like we have kinetic energy is half mv square is equals to ke. If I multiply and divide this equation by m, so it will be m square v square over 2m is equals to ke. So it means the momentum square, m square v square is the momentum square divided by 2m is equals to ke. Or momentum square is equals to ke times 2m. So if ke is same, the one which is massive will have the high momentum. So using this formula, you can find a relation with the mass and the momentum for small particles. In this question, we have portable electric heater with a power of 280 watts. It is used to boil water for a hot drink. The heater is placed into a cup of water. There is 165 gram of water is there inside the cup. Initial temperature was of water was 12.5, and because we want to boil, so final temperature should be 100. Assume that all the energy from the heater is transferred to water. The heater is used in London, where the boiling point of a water is 100. The boiling point can change from place to place depending on the atmospheric pressure. Show that the time for the heater to reach the temperature 100 is about 220 seconds. The specific heat capacity is 4190 joule per kilogram. This is important part, like if the specific heat capacity is given in joule per kilogram Kelvin, so the you should have this in kilogram, and the temperature should be in Kelvin as well. But normally, because when we are calculating a temperature change, we don't have to convert the units. Reason is that because if the temperature, always remember the temperature change in degree centigrade is always same as temperature change in Kelvin. Temperature change. I'm not saying temperature in degree centigrade is equals to Kelvin. That's wrong. I'm saying if we take a difference in temperature in Celsius will be same as the difference in temperature in Kelvin. Or it's better to be on the safe side, always try to convert the temperature into Kelvin. So for converting degree centigrade into Kelvin, you will add 273. So this is 12.5. So 12.5 is there. We'll add 273, which is equals to 285 point. So this is equals to 285.5 Kelvin. And when we add 273 to this one, this will become 373. But when I take a difference in the temperature, like if I do 100 minus 12.5, which is 87.5, and I take a difference of these two, I'll get the same temperature change. So it won't make difference. And the mass should be in kilograms, so we divide by 1000.165 kg. Now we have the formula, the energy change is equals to Cm delta T. Whenever the temperature is changing, the energy absorbed or released is given by a formula Cm delta T, where C is a specific heat, 4190. M is a mass, which is 0.165, and temperature change. The temperature change is about in Kelvin or even in Celsius, it will be both 87.5. So this will give us how much energy is being absorbed. So after getting the energy absorbed, so what's the answer for this part? When we work out 4190 times 0.165 times 87.5. How much is the energy absorbed? Yeah, that's 60,493. So the energy absorbed, so the energy which is absorbed is equals to 60,493 joules. But we need the time, so we have the formula. Power is equals to energy divided by time. So energy will divided by power because we need a time, so equals to time. So energy we have 60,493 and the power of the heater was 280. So when we divide, this will give us answer as 216 seconds. So this heater will take 216 seconds to supply, like change the temperature of this water from 12.5 to 100. The next part of this question, the same heater is used in the world highest capital city Israel, La Paz, where the boiling point is 87.7. The mass and the initial temperature of a water are the same. The heater is used for the same time. Calculate the mass of a water converted into vapor. As the water boils, the specific latent heat of vaporization is given. For the water, the specific latent heat of vaporization is also given. In this case, what will happen? The first two things we have to do. First, we have to increase, like we have the same amount of water, all the parameters are same. Only difference is the boiling point will be different. So a container is there which is filled with 165 grams of a water. So when we use this immersion heater, first the temperature of this water will change from 12.5 to 87.7 degrees. And then it start to boil or turn into vapors. So the energy which is supplied by the heater, the total energy supplied by the heater will be first, because we need the energy, like first energy we need to reach a boiling point from 12.5. So that energy will be Cm delta T. And the second energy, we want to vaporize, we want to change the state. So it is mass into latent heat of vaporization. So M into LB or M into L also you can say whenever you need the change state. And the total energy which we supplied will be equal to E1 plus E2, or we can say the total energy which we supplied, that is Cm delta T plus M into L, that is equals to total energy supplied. And how we know how much energy we supplied? Because in a dimension, same amount of energy supplied, so energy is power multiplied by time. So power was 280 and the time it's 216 seconds. Our answer, if for example you're not able to get the answer for previous part, you can use 220. So the total energy which we supply here, so the total energy which we need or total energy which we have to supply here, that is equals to the specific latent heat into mass plus Cm delta T. So we'll just substitute the values. And what we are finding how much water is being evaporated, like converting to vapor. So this is the unknown which we are finding. So just substitute the value. So it will be power into time is equals to Cm delta T plus M into L. This M is what we are finding, like how much water is being vaporized. Initially, we were having 0.165 grams, 0.165 kilogram of water. As it was given in grams, so we convert into kilogram. So just substitute the values 280 times 216 specific 4190. The mass was 0.165. The temperature change this time, it will be 87.7 minus 12.5. So because whenever we need a temperature change, we don't have to convert into Kelvin, and because the temperature change in degree centigrade and Kelvins are equal. This M is unknown, and the latent heat of vaporization is 2.29 into 10 power 6. So we just solve this and get the mass. The final answer, the mass will be about 0.00371 kilogram. That will be the mass of the liquid which will be vaporized. So for this question, air can be considered as an ideal gas. So if we consider ideal gas, we can apply the gas laws such as Boyle's, Charles, and pressure. A sample of air with a volume 2 exponent minus 3, a pressure is there, and temperature 298. Calculate the number of the molecules in the air. So if we know the temperature, pressure, and volume, how to find the number of particles? So the formula is PV is equals to NKT. This is a formula always. So PV equals NKT, where P is the pressure, should be in Pascal. V is the volume, should be in meter cube, SI unit. N is the number of the particle. K is the Maxwell-Boltzmann constant, which is 1.38 into 10 power minus 23. And the T is the temperature, which is 295 Kelvin. So when we divide, we'll get the number of particle, which is about 6.63 exponent 22. So this N will be 6.63 into 10 power 23. So 22. After getting the number of the particle, so PV is equals to NKT is the formula which relate the number of the particle, pressure, and volume. Then a fixed mass of a air as its initial temperature 12, the internal energy of air is double. Calculate the final temperature. So if we need the final temperature, we know the kinetic energy and is proportional to, like here, a fixed mass is there. The number of particles are not changing. Initial temperature was 12. The internal energy is double. Calculate the final temperature. First thing, as I remember one thing, when temperature double, the kinetic energy will also be double. But temperature should, in Kelvin, should be double. Where the initial temperature is there. So first what we'll do, we'll convert this into Kelvin. So 273 plus 12, so it will be 285. So this will be 285. If the internal energy doubles, because internal energy increases as the kinetic energy also increases. If the kinetic energy become double, the internal energy will also be double. So if 285 Kelvin is there, so what is the double of 285? So this will be 590 Kelvin. So final temperature will be 590 Kelvins. And how we relate this, we will simply mention that, because you don't have to use any specific formula here, just your understanding that internal energy is directly proportional to temperature, like kinetic energy proportional to temperature, same as internal energy. So if internal energy is double, temperature should also be double. But student forget the conversion of temperature, like or temperature in Kelvin is double. It's not like if it was initially 12 degrees and it become 24 degree. If the temperature here is double, the kinetic energy will not double. Why? Because this is the temperature in Celsius. If temperature in centigrade or Celsius scale is double, the kinetic energy or internal energy is not double. That is wrong. If the temperature in Kelvin scale is doubled, then the internal energy will also be doubled. So you have to predict a temperature. So how to answer this? You will mention when the temperature is double, it means that when internal energy is double, so temperature in Kelvin should be double. So if the initial temperature was not 12, it is actually 285 Kelvin. So what double will be 590. So we just have to predict the final temperature. So one mark is for relating internal energy with temperature. One mark is for converting the initial temperature into Kelvin scale. And the final mark is for getting the final temperature.